All right, so we've been working with the three fundamental trig identities, the ratio, the reciprocal, and the Pythagorean. What we're going to do now is we're going to branch off into more identities, as well as what we get into is as far as formulas go. We kind of treat them as identities, but they're really formulas. The first ones I'm going to show you are called the even and odd identities, and I want to explain why they're called the even and odd identities. So even and odd. Oh, let me turn my board on. So even, odd identities. And what I'm going to do is I want to just write them down, make sure you have them in the notes, and I'm going to go through them and explain why they work this way. Even and odds are one of the most used identities that I use because I never deal with negative angles. I always use the even and odd identities to tell me what to do with my negative angles. So in this case, if I have sine of a negative angle, that's the same thing as saying it's a negative sine of that positive angle. When I have a negative angle for cosine, that's just basically telling me it's just cosine of that angle. Sine, cosine, and then tangent is going to be a negative tangent of that angle. Now the reciprocals are going to follow these same rules. So the reciprocal of sine is going to be cosecant of a negative angle. I'm just going to put the negative on the outside. And then, let's see, the reciprocal of cosine is going to be secant. And at that point, we're just going to do secant of its positive angle. And then the reciprocal of tangent is cotangent of a negative angle is going to be negative cotangent of that positive angle. All right, so these are your 6 even and odd identities. The reason why these work is because in Algebra 2, you learned about an even odd function. When you used to plug in, if you did f of negative x, if you got f of x, it was an even function, and the even function told us it was symmetric across the y-axis. Basically, if you folded the function in half, it would be a perfect match. If you put a negative x into your equation, you got a negative f of x, meaning that every single sign changed. That was an odd function, and that means it was symmetric about the origin, meaning that if you took it and rotated it 180 degrees, then the graph would perfectly match. Now, let's take a look at sine. I have sine right here. Now, if you look right at the origin, you have this part here, and if you take it and rotate it over, this top part is going to match up perfectly. So it's symmetric about the origin, therefore it is an odd function. So that means I'm going to have my negative on the outside. If I take a moment to look at cosine, cosine being right here is your maximum. If I take this graph and I fold it over, it would perfectly match up. That makes it an even function, meaning that there is no negative here. So I could do this with the rest of these, but I want to show you a trick to memorize these and memorize them fast. I got this from Ms. Hawkins several years ago, and this is the easiest way I've ever seen. I've always said, and I've always been taught, sine, cosine, tangent, sine, cosine, tangent. In my class, I've always said sine, cosine, tangent, sine, cosine, tangent. And then I would write the reciprocals, cosecant, secant, cotangent, always in that order. Well, for the even and odd functions, well, I don't know if it was done this way on purpose, but it's a pattern that we're going to be able to exploit. If I just number them 1, 2, 3. If I pick the odd numbers, those are my odd functions if I go sine, cosine, tangent. Sine is 1, 1 is odd, therefore it's an odd function. 3 is an odd number, therefore tangent is an odd function. 2 is an even number, that makes cosine an even function. This only works if you always say sine, cosine, tangent, but that's how I've been saying it all year, and that's generally how you're always going to hear these three put together is sine, cosine, and tangent. So these are your even and odds. A quick example of this is, say I wanted to do sine of negative pi over 4. I could type that right in the calculator. I could go to my unit circle and look for it, or I could just move this negative on the outside, do negative sine of pi over 4, and they are the exact same answers. You never have to deal with negative angles again. As long as you're using the even and odd, you never have to deal with negative angles again. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.